In this video, I'm going to show you how to forecast or what to look for when you forecast for severe weather. So again, I'm on Pivotal Weather or I'm using the Pivotal Weather site. And when you log into this page, it automatically defaults to the National Weather Service current hazard map. And there's a key at the bottom, but here what you notice down in Louisiana and Mississippi is that you have a lot of these greens and yellows, oranges and reds. And so basically, it's already highlighted for you because it's being designated on the map. And so they're looking at tornado warnings, tornado watches, severe weather, flash flooding. So they're looking at a lot of strong, severe thunderstorm activity down in the Gulf Coast. So to kind of just look at, that in more detail, what I'm going to do is I'm going to click on models, and I'm going to just start off with the continental United States just to kind of see what's going on. I'm actually just going to do the forecast loop here, and I'm going to use my key, my greater than, less than arrow, just to move. And so what I see here is that here is a area of low pressure, quite strong area of low pressure, pretty well developed. We have a pretty good area of circulation here, 1001 millibar low. And so you can see that here it's this area of low pressure that is moving through the Gulf Coast. Okay, so already I can see where my trigger is. I already know what my trigger is. So when I look at my thunderstorm checklist and I'm looking to see, what do I have in order to generate thunderstorms, I can already cross trigger off the list. We have that. It's this area of low pressure. And also what you notice here is that here, these red dash lines, these would be the 500 millibar heights. And so if we were looking at 500 millibars, you would actually see a nice big trough where the trough axis basically cuts right through Oklahoma and Texas. So remember, cut the trough in half. My low pressure will be on the right, my high pressure will be on the left, and so when you have high pressure on the left, that's usually associated with cool air that's coming down in from the north or the northwest. And so here we have an area of high pressure. We have another cell of high pressure right here. There's just no H indicated, but here would be our area of high pressure. And so here we would expect cool air being brought into the Louisiana-Mississippi border. And so here I can see all my red lines are out above this, and so I have higher heights as I go further south. So I know that my warm front is actually extending ahead of this area of low pressure. So when I move forward in time, I already have my trigger. I know that I have a lot of moisture here. I can see based on the projected reflectivity that there is a lot of reflectivity here, and so I know that there's going to be a lot of action. So just to see how much, let's dive into a little bit more different parameters. So now what I want to do is I want to click on the severe weather tab here on the left. I want to click on severe weather, and I'm going to click surface-based CAPE. So I want to look at the CAPE levels. And actually what I'm going to do to make this a little bit easier, I'm going to zoom in on this region. So let's zoom in on the south central US. Okay, and that will give us a good indication. So now let's move this forward here, okay? And we can see how CAPE values basically change. So down here on the lower end would be about 500, and then on the upper end would be over 9,000. So if you just move this through a little bit, you can see here by Thursday at 18Z, you can see all the different values of CAPE. And so it's not extreme, but it is pretty solid. And so, we have, 1347 joules per kilogram. So they're over 1,000. It's a little bit weaker as you go north. It's mainly in the, the 5 to 600 range. But, here in this area, okay, you can see that this is your biggest area, or you have the most energy in this region. And so based on that, I expect the more severe weather to happen where there is more energy, and that makes sense. Now another parameter I actually want to look at is what we call surface-based SIN. And so SIN, that's that capping inversion. It stands for convective inhibition, and it is the capping inversion that we talked about in the previous video. And so here what you notice is that you see a bunch of negative numbers. So a more positive number would indicate a stronger capping inversion. And so the more negative numbers you have, the more willing air is to rise. And so what you notice here is that here, when we look at SIN, especially in the area that there was the highest cape, we actually have the lowest sin. So we're talking about almost, minus 600 joules per kilogram, of air that wants to rise, more or less. And so again, it's right in the Louisiana panhandle, I guess you can call that, or in the boot of Louisiana, and also the border of Mississippi. So that's another thing that you can look at. Again, you can also look at bulk wind shear. And so what did I say? We're looking for about 30 knots of wind shear, more or less. And here we got plenty of that, 50 knots of wind shear, a little bit less, as you get further south towards the coast. But again, we have very strong wind shear. And here you can see what the upper level winds are doing. You can see where that trough is. If you look at my mouse, you can see what that trough is doing. So here would be the trough axis. Okay, cut right through central Texas. So here you can see where these winds are traveling. So you know that the storms that are generated in the area with the best ingredients is going to move towards the northeast. And so that's the way that these systems are looking to track. And so that's why when you looked at the hazard map, it showed that this whole area was basically prime for any kind of severe weather. So we have plenty of cape. We have a very, very low sin number. We have great wind shear, and we have a trigger. And so here you can see where all your active convection would more or less take place. And so just looking at the current radar, because this is actually going on right now, when we actually look at the current radar, here you can see, and actually I'm going to back this up and I'm going to actually do a regional view. There we go. So when we actually look at this and when we loop this image, you can see how all the storms are traveling where the upper level winds are taking them. Okay, so this is what severe weather would look like, and you can see here where all the darker reds are. This is the reflectivity. You can see where all the darker reds are and oranges is pretty much in that area, that same area on the bottom portion of Louisiana and even up into almost the Mississippi-Louisiana border. You can see here that right basically where my mouse is circling, that this was the area where we had most of the ingredients for thunderstorm development. And so here you can see that this is where the strongest thunderstorms are actually being produced. So when you go and create weather forecasts, you can actually use these tools, and you can use these checklists, and you can use pivotal weather to actually see where you have the best ingredients, and you can see where or what locations would be the best locations to predict severe weather to occur on a certain day.